So now that you know how to find maxes and mins, increasing, decreasing, concavity, and all of that from f of x, f prime of x, f double prime of x, we also want to be able to figure out where the global maxes and mins are located. For example, if I have this graph here, and it stops here and it stops here, I want to be able to figure out how high it actually is and how low it actually goes. And most of the time we're looking at the y value, so the global max would be whatever that y value is there, and the global min would be that y value there. And we want to be able to do that, again, without the calculator. We are given y or f of x, but we want to be able to figure out what the graph would look like and find those y values without a calculator. So we're going to start like we had before, find the derivative, set it equal to 0, and solve. So then that gives us our number line. Just like we've done before, we're going to think about f prime of x, or y prime, which is the 2x minus 2. We're going to plug numbers into that. So 0, I get a negative. If I plug in a 2, I get a positive. So what I know is that let's see, I forgot to tell you what interval we were looking at here, because there's an interval. It's important to know that this particular problem, there wouldn't have been a max or a min, a global max or a min. There would just have been a min at 1, but because I'm giving you an interval, I'm telling you that it stops and starts. It starts at 0 and then it stops at 3. So there is a local min at x equals 1 because f prime changes negative to positive. But what I need to know now, 0 is here, and 3, I think I'm going to do that in a different, so that you can see it better. Here's 0 and here's 3. So in that particular interval, I'm trying to figure out where the global mins and maxes would be. I know there's a min at 1, and so thinking about what the rest of it is doing is important. Now I'm just going to copy that slide over. Okay. Now, what I do know is that f of x between 0 and 3 decreases, then it increases. And that statement right there helps me figure out what's going on at 0 and at 3. So I have a graph that decreases and then increases. This is that min that I know that I found at 1. What that tells me is that 0 and 3 are both maxes. Now, we don't know which one's global, but what we know is that x equals 0 and 3 are maxes. And the reason is this statement here. Now, I draw the graph usually when I write that statement because it helps me look at it and tell. They're both maxes because they're higher than the points around it. And so we need the statement to say what's going on in between 0 and 3, like what's going on at 1. But then we also need the statement to explain what's happening at 0 and 3. And that usually you just describe f of x, and that tells you what's going on. So from there, to find the actual global min or max, I need to know y values. So I make a table, and I usually separate the mins and the maxes. I know that these are the maxes, and I know that this one was the min. And I'm going to plug those values into the original equation. The original equation was x squared minus 2x plus 2. So I'm plugging 0 into that. I'm plugging 3 into that. And I'm plugging 1 into that. I already know that 1 is the min, so that must be the global min. And I know that 0 and 3 are both maxes, but the one that is the biggest is at 3. So the global max equals 5. Your answer is what the actual y value is, unless it says where does the global max occur. Normally it'll say what is the global max. Okay, here's another problem. We're going to start by finding the first derivative. It's really just one more step in what we've been doing. That should have been to the, yeah, that was to the fourth, that was right. Sorry. So we have 15x squared, or to the fourth minus 15x squared. Set that equal to 0, factor out whatever's in common. I know that'll give me 0. If I move the 1 over and then take the square root, it's going to give me plus or minus 1. So my number line, I'm going to have -1, 0, and 1 on my number line. My interval is -2 to 2, so I know that here's the -2. I know that here's 2, so I need to know everything about that interval. Alright, if I plug some numbers in, remember I'm doing it into the first derivative, which is this equation here, or I could use this one, either one. You should get positive, negative, negative, and positive. So then, let me write that just one more time, just so that you can see it as I talk about it. That means that there's a max at x equals -1 because f prime changes positive to negative. There's a min at x equals 1 because f prime changes negative to positive. 0, there's not a max or a min at 0. It may be a point of inflection or something, but for now, we don't know what that is. Alright, again, here's our -2 and our 2. So you then make a statement about f of x. And sometimes I'll say between, but you don't have to. Look at the first derivative. F of x increases, decreases, then increases. Now, I'm going to draw a little graph that helps me think about that. So increasing, decreasing, increasing. There's my two endpoints. That means that there is a min at x equals -2, and there's a max at x equals +2. And I can just tell by thinking about the way the graph looks. And I know that the graph may not look exactly like that, but that's a good sketch just to be able to figure out what we're trying to figure out. And this statement right here explains why there's a min there and a max there. So then I make my little chart. I'm going to go ahead and just make two charts so that I don't run off the screen. Here's our maxes. Here's our mins. Go ahead and plug those values into the original equation. And then so my final answer, I'll write up here at the top. Global max is 55 because 55 is bigger than 1. Global min is -57 because -57 is the smallest. So those two tables show me all the mins and maxes, all the possibilities of where the globals would be. And once I figure out which ones are which, I just sort of look at them and I can pick out. These were maxes and these were mins. And then I look at those values to see which one is the biggest and the smallest. Now, what if we use the same problem from number 2? So we've already made the number line. But this time, I want to go from 1.5 to 4. Now, I actually think I wrote that wrong. I really want to go from 0.5 to 4. So 0.5 is about here, and 4 is up here. So if that's the case, if what I'm looking at is something like that, then when I make all of my descriptions, my descriptions are based on what's going on between 0.5 and 4. I don't really care what's going on down here. So when I write all of my things, I'm just telling you what's going on from here to here. So between 0.5 and 4, there's a min at x equals 1 because f prime changes negative to positive. And let's figure out what's going on at the endpoints. So f of x decreases, then increases. So decreases, decreases, then increases. So that means that from 0.5 to 4, that they're both maxes. So there's a max at x equals 0.5 and 4. So then, after I know what's going on, I make my chart. I know that 0.5 and 4 are maxes, and I know that 1 is the min. Go ahead and find the x and the y values. At 0.5, when I plug that into the original equation, I get negative 1.531. At 4, I get 2751, and at 1, I get negative 3. Looking at that chart now, I know that the global max is 2751, and the global min is negative 3. So it's kind of basically the same thing as number 2, except less information because I was only looking at 0.5 to 4. Okay, number 4. So let's say, again, same problem, same number line. This time I'm only going from 2 to 4. So I don't care about all this other stuff. Although it's important, I really just want to know what's going on from 2 to 4. And so what I know is that between 2 and 4, f of x increases. That's all that's going on. Because there's 2 and there's 4. It's always increasing. There's no min or max between there except what's going on at the endpoints. So since it's always increasing, it kind of looks like this. That means that x equals 2 is a min and x equals 4 is a max. So then once I figure that out, I can just go ahead and make my little chart, find my x and my y's. X was 55 there and 2751. So my global min is 55 and my global max is 2751. I realize you could look at that and not write this statement right here and be able to tell me that 55 is the global min. However, they're looking for all of the work. They're looking for you to show every little piece of it and to show your reasoning. So you're going to have to write that statement to explain what's going on at those two endpoints. Alright, here's 2 try problems. The first one, you're going from negative 4 to 0. It's more of a traditional kind of problem where you find the derivative, set it equal to 0, make the number line, and then find everything that you need to find. Make sure you make your explanations. Number 2 is kind of, it might throw you for a loop, but it's not that bad. Just be careful as you're doing it and pay attention. I'm giving you f of x. I'm also giving you f prime, so I'm not even asking you to find f prime. And then I'm asking you to make a number line and find the mins and maxes and everything. This one's kind of strange because it doesn't ever equal 0, but you can use the places where the derivative is undefined to make your number line as well. And then go from negative 1 to 3. So I think that'll be okay. Try both of those, and we'll talk some more about it tomorrow.